Hi, this is Peter Weiss, and this is my Lab 9, the Advanced Traffic Simulation. And this is the simulation I have on Logism. Right now, nothing is set, which is why all these things are red, but if I, so that's the same as resetting the simulation, but if I have this reset button here, so once I hit this is a synchronous reset, and I hit the clock, it resets everything, and the initial state is what I defined as state 7, which is all the lights, these three lights red, and the bravado left turning light is yellow. So this is the finite state machine. This is the next state logic. These are the registers, and this is just the output logic. Here I designed these, I think, neat little left turning arrows using these LED arrays. So this is the academic road. Here's the left turning signal, and here's the straight signal, and this is bravado. Here's the bravado straight signal, here's the bravado left turning signal, and here are all the inputs. I changed the inputs a little bit because I thought it made more sense to me to just have sensors for when there is traffic going straight in a certain direction on each road and when there's traffic going left. So this is for traffic on academic going east, that's going straight, traffic for academic going west, that's going straight, traffic for academic that's going left and it's going east, traffic that's going west that's also making a left, and the same thing for vibrato, traffic that's going straight or left, and depending on which way it's going, north or south. And basically the only thing you need to tell, you don't need to distinguish between the east and the west, you only need to tell if it's going straight because that light only that controls whether it's going straight, not whether it's going east or west on the road. So I just ORed them together, and in fact I used a NOR gate to invert it because it was better for my logic. And yeah, so if I now start ticking the clock, and if I enable the ticks, it will just go back and forth between the different states. So first academic gets, first academic gets to go straight, then there's yellow, then academic gets to turn left, then bravado gets to go straight, then bravado gets to turn left, and you see after each time the light turns green, it immediately turns yellow because there's no traffic on any of the roads right now. So it's just going back and forth between the 8 different states I defined using these 3 bits. But if I add traffic somewhere, say traffic in academic going straight, then this light here will stay green until there's no more traffic. So I can change this. As long as there's traffic, it'll keep going green, but then once there's no traffic, it will allow it to go to the next state. So I can add traffic in other places, like turning left on academic. So now this will stay green until I turn the signal off. And now say going left on bravado, which will make this stay green until I turn the signal off. So I can do that for all the different signals, and it will keep whatever light is necessary green until that signal is turned off, no matter how many clock ticks happen. So yeah, I can change these inputs and play with these inputs, but basically, so now bravado left is still green, but once I turn bravado left off, it will change. And now we'll stay on academic left because this signal is turned on. Once I turn it off, it'll change. And now we'll stay on bravado straight until I turn the signal off, and it'll change. So this is a representation of a traffic light controller using the finite state machine, these arbitrary inputs here, and a visualization of the output using these LEDs. Thank you.